All right, we are back for part 2 of 10.4. The first part of this, you're going to hopefully remember some of this from geometry. So a painter needs to lean a 30-foot ladder against a wall, and the safety guidelines recommend that the distance between the base of the ladder and the wall should be 1/4. So put that in there, the 1/4 of the length of the ladder. To the nearest degree, what acute angle should the ladder make with the ground? So to the nearest degree, what acute angle should the ladder make with the ground? So you have a wall, and then they are leaning the ladder against that wall. Here's my ladder. And then we want to know what acute angle should the ladder make with the ground. So this will be my ground here. This is going to be a right triangle because we are going to use our trig functions. So this is what I'm trying to figure out. This is my theta value. Okay, now I do know that the ladder is 30 feet long. So this side of the triangle is going to be 30 feet. And it says the distance between the base of the ladder, okay, and the wall should be 1/4 of the length of the ladder. So that would be 1/4 of 30. So if we do 30 divided by 4, we'll get 7.5 feet. And now we are going to find our theta value. So remember, when you're working with your right triangle, you can think of this is your hypotenuse, and then if this is the angle we're trying to find, this is the adjacent. So remember SOHCAHTOA? So if it's sine, opposite hypotenuse, and then cosine is adjacent and hypotenuse. So the cosine of theta would equal the adjacent over the hypotenuse, which means the cosine would equal 7.5 over 30. Now, if you want to solve for theta, what you're going to do is you are going to use the inverse cosine. So theta would be the cosine inverse of 7.5 over 30. This is to find the angle. Really, what's happening when you do that is you are doing the cosine inverse of each side. So if you did the cosine inverse of cosine, those would cancel out and you'd be left with theta. And then when you do the cosine inverse of 7.5 over 30, you're going to find that angle measure. So you do want to make sure that your mode is in degrees for this one. Okay, so mine already is. So I'm going to do the cosine inverse of 7.5 over 30, which gives me 75.5. And then it says we're rounding to the nearest degree, so this is going to be 76 degrees. All right, for example 2, it says a road has a 5% grade, which means that there's a 5-foot rise for 100 feet of horizontal distance. Okay, at what angle does the road rise from the horizontal? And then this time we're rounding to the nearest 1/10 of a degree. So now that I know this is going to be a triangle, I might do that part first. I might just draw my triangle. And this is a 5-foot rise for 100 feet of the horizontal distance. So the rise, it's like the rise over the run, right? This is your horizontal, this is your vertical. And at what angle does the road rise from the horizontal? This is your road. So this is going to be your theta value. And then again, we can label these. This is the opposite, this is the adjacent. So now I know I'm going to be using the tangent. So it equals the opposite over the adjacent. You can reduce, you don't have to, but 5 over 100 is 0.05 or 1/20th. We're just going to use our inverse function. And now it says we're going to round to the nearest 1/10. My picture obviously isn't drawn to scale. If this represents 5 feet, the 100 feet would be a lot longer. You really don't want to see that steep of a rise in the road, especially if you're not driving up it, if you have to bike up it or walk up it. All right, and then your theta value, we had 2.86, so because we're rounding here, will be to the nearest tenth, will be 2.9 degrees. All right, so both of those were based on different skills that you learned in geometry. Now we're going to talk about some of the restrictions again with your inverses. So this says to solve each equation to the nearest tenth, use the given restrictions. Before we were finding the exact values, the sign of theta here is 0.4, so that's not an exact place on the unit circle. And then it gives you a range of values that theta can be. Okay, so theta has to be in between negative 90 degrees and 90 degrees. All right, so I like to draw a visual representation first. If it's between negative 90 and 90, then that means I start at negative 90 and go to 90. That's going to be what quadrants? Quadrants 1 and 4. So this is actually the same as the restrictions of the inverse sine function. Okay. Now we are going to write an equation and then solve that equation. So I'm going to say write an equation and then solve. Okay. So we have the sine inverse, or sorry, the sine of theta equals 0.4. So if I want to find theta, I just have to do the sine inverse of 0.4, 0.4. And sorry, my phone. Okay, and then we are going to do the sine inverse. Okay, and then it does give you that in degrees, so that's in degrees. And it said that we are going to round to the nearest tenth, so then your theta value is going to be 23.6 degrees based on what you get on your calculator. Alright, and then we are going to go to the back, and I'm going to make a new video for that one.